Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of attributes of quadratic function graphs. This is standard A.7A in the great state of Texas, and we are using item number 50 off the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have this graph here, and we are looking for the coordinates that best represent the vertex. So let's take a moment and find all the things we do know about this graph. All right, so we are going to look for the vertex here, but we can also find the minimum value. We can also find our y-intercepts, our x-intercepts, which we need to remember that the x-intercepts have other names such as zeros. Sometimes they're called the solutions. We can even find the axis of symmetry. Those are all things that we can use to describe quadratic function. There's many aspects here. So let's start from the bottom here and work our way up to get to our vertex, because we're going to find the numbers we need for the vertex actually in two other of these values here. So what is our axis of symmetry? Well, the axis of symmetry is an imaginary line that cuts this exactly in half. And if you wanted to fold your parabola in half along this axis, it would be exactly the same, congruent on either side. So that's symmetrical mirror reflection. So you see that line right there? Your axis of symmetry is always going to look like this. It's always going to say x equals, right? As long as you have a parabola that opens up or opens down, not sideways or rotated or anything, it's going to just give you the x value. So what x value, no matter what the y value is going to give you that axis of symmetry, and it's right there at that 1. So x equals 1 is going to be the axis of symmetry equation right there. Now, what are the x-intercepts? Well, right now we can just estimate them, right, unless we actually find the equation and then use the diamond method to kind of manually calculate the zeros and factor them out into binomials. We're just going to estimate them. It looks like that's about -1/3. And probably about 2.5. Now those are just the x values. Obviously, if we wanted to make them coordinate pairs, right, we could do -1/3, 0. We can say 2.5, 0. But we know that if they are x-intercepts, then their y value has to be 0. That's one of the reasons why they're called zeros. It's the x value that makes the f of x equal 0. All right, so we have one y-intercept. That looks to be an integer right there. So that is going to be -1. Once again, we typically just refer to the y-intercept by the y value, -1. Want to make it a coordinate pair, it's going to be 0, -1. But that's just kind of assumed because any y-intercept is going to have an x value of 0. Now what is our minimum value? I know we have a minimum value because it's an upward-facing parabola. So an upward-facing parabola is always going to have a minimum value. If it was a downward-facing parabola, it would be a maximum value. Well, the lowest it's going to get is -2. So the x's are going to go from infinity to -infinity, but the y is going to go from -2 up. That's the minimum value. So finally, we're going to get to our vertex right here, which we could have just graphed. But I want you to see that the vertex actually has the x value of the axis of symmetry and the y value of your minimum or maximum value, depending on which way it opens. So your axis of symmetry is 1. Your minimum value is -2. So that is going to be our answer. That's the vertex, J.